Let's understand the concept of collision theory of reaction rates. This theory is based on the assumption that collisions between the reactant molecules are responsible for the formation of the products. And this theory is basically based on the kinetic theory of gases, which you had learned in 11th standard under the heading of states of matter. Let me explain what is the meaning of collision between the reactants leading to the formation of the products. If this is the reaction vessel, if these are the molecules of one type of reactants and the molecules colored with red are the molecules of the second substance. So according to this theory, the reactant molecules are assumed to be hard spheres and the reaction progresses whenever the reactant molecules collide with each other. Means the molecules colored in green need to collide with the molecules colored in red. Then only formation of products can take place. Suppose the molecules colored with red, only they are colliding with each other. Only exchange of energy takes place between them and that will not lead to the formation of the product. So in order to form product, definitely the molecules of these reactant should collide with each other. So only collisions between the reactant molecules lead to the formation of the products. Thus the reaction progress further. And the number of collisions per second per unit volume of the reaction mixture, this is called as the collision frequency, which we can represent with alphabet Z. And this value of collision frequency is very high. For example, under the normal conditions of temperature and pressure in a gaseous system, the collision frequency of the binary collisions is in the order of 10 power 25 to 10 power 28. Means whenever we are taking the reactant molecules of two different substances and when they are colliding with each other, that's the meaning of binary collisions. And the collision frequency, it ranges in between 10 power 25 to 10 power 28. Means that many number of collisions takes place per second per unit volume of the reaction vessel. And if you assume that all these collisions leads to the formation of product, then definitely that will be wrong. Because if all the collisions are effective in the formation of products, definitely the reaction must be completed in very short period, isn't it? When these many number of collisions are taking place between these reactant molecules, and that reaction will definitely be completed in very minute time. But however, in actual practice, most of the chemical reactions are slow and take much longer time for their completion. So we can conclude like this, that all the collisions among the reacting species at a given temperature are not effective in bringing about the chemical reaction. So those collisions which actually produce the products and therefore result in the chemical reaction, they are called as effective collisions. So what is the meaning of effective collisions? Those collisions which result in the formation of the products due to which the reaction is progressing further, those collisions are called as the effective collisions. Just see this animation in order to understand the concept of effective collision and ineffective collision. In the first case, the two molecules are colliding with each other and without any formation of product, they are bouncing back, isn't it? So this collision does not lead to the formation of the product. And these kind of collisions, we call them as the ineffective collisions. Now take the second case. So after the collision of the molecule A and B, products are formed here. So these are the collisions which leads to the formation of the products. So out of all the collisions taking place in the reaction vessel, some leads to the formation of the products and some does not. And those which leads to the formation of the products, like the second case here, we call this one as the effective collisions. Whereas the other one which is not leading to the formation of the products, this one we call it as ineffective collisions. Is it clear now? Yes, let's move further. So how can we say that the collisions lead to the formation of the products or not? Actually, that depends upon two factors. One factor is the energy barrier. The second factor is the orientation barrier. Let's understand this one by one. Here is the information related to the energy barrier. For the reacting species to make effective collisions, they should have sufficient energy to break the chemical bonds in the reactant molecules. So the existing bonds in between the reactant molecules need to be broken. Then only they will combine with atoms of different element in order to form products. And for this process, some amount of energy is required. And what is that energy? And the minimum amount of energy which is required by the colliding molecules in order to form products, that is called as threshold energy. What is the threshold energy? The minimum amount of energy required by the reactant molecules in order to form products, that is called as the threshold energy. Unless this energy is not present with the molecules, even though they collide with each other, that will not lead to the formation of the products. So we can call that one as ineffective collisions. So whenever the reactant molecules possess the energy equal to threshold energy, and when they collide with each other, then only results in the formation of the products. And such kind of collisions, we can call them as effective collisions. Let me explain this concept by using the animation. Here, whenever the energy of the reactant molecules is less, they are unable to cross the energy barrier, and that is the reason why after collision they are rebouncing back and products are not formed. And already we had learned in the same session that these collisions which are not leading to the formation of the products, we call them as ineffective collisions, isn't it? So in this case, reactant molecules are not satisfying the energy criteria. The reactant molecules does not possess the minimum amount of energy, that is threshold energy, in order to form products. But see this case, whenever the reactant molecules possess high kinetic energy or the required amount of kinetic energy, they cross the energy barrier, and that results in the formation of the products. See here, products are formed. If you want, you can again see the first one. This is the case where the reactant possesses low kinetic energy. So only normal collision, no product formation. They are rebouncing back. See, when they possess high kinetic energy, they are crossing the energy barrier in order to form the products. And that is the difference between the normal molecules and the activated molecules. So only effective collisions leads to the formation of the products. But under the given experimental conditions, the energy of the normal reactant molecules is always less than the threshold energy. And threshold energy we can simply represent as ET. So under the normal conditions of temperature and pressure, the energy of the normal reactant molecules is always less than the threshold energy. Means under the normal conditions, as the energy of the reactant molecules is less than threshold energy, definitely even though they collide with the other reactant molecules, that will not lead to the formation of the products. So what they need to do? Hence they need to acquire some additional amount of energy in order to make their energy equal to threshold energy. And the additional amount of energy the reactant molecules must acquire in order to form products, that is called as the activation energy. So what is that activation energy? Each and every molecule is having some amount of energy. That one I will write like this: energy of the normal molecules. And in order to form products, the energy of all these reactant molecules should be equal to threshold energy. But under the normal conditions, the energy of the normal molecules is always less than threshold energy. So they need to acquire some additional amount of energy in order to form products. And that additional amount of energy and the original energy together, if that becomes equal to threshold energy, that only leads to the formation of the products. So that is the reason why Activation energy is equal to threshold energy minus energy of the normal reactant molecules.